Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem. Just attempt to solve the problem, talk through my thought process, and hopefully it's useful to someone watching this. So the problem that I'm going to be attempting today is from LeetCode's 150, and it's this problem here, container with the most water. So I'm just going to read out the spec here. You're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height I. So, find the two lines that together with the x-axis form a container such that the container contains the most water, and return the maximum amount of water a container can store. Note that you cannot slant the container. So here we've got 1, 2, 3, 4, 5, 6, 7. 7 times 7, so this is 49. 49, I'm just going to say units. It can hold 49 units. So we basically have to find the greatest amount of water that can be held. I'm seeing here that there's some hints. This is using some topics. Let's see. 2 pointers is something that it was quite a basic sort of concept, but I've not answered many questions that use this kind of technique, I guess you can call it. So I'm gonna have a look at the first hint. If you simulate the problem, it will be O of n squared, which is not efficient, which is true. If you were to go check here, then here, then here, then this, like if you were to go through every single possible like permutation, you could simulate all the different volumes of water that you could have, but it would be very, very inefficient. It would be over n squared because you'd be doing a loop that would be O of n, then within that loop you'd have another O of n loop, so it'd be O of n squared. So we know that. Hint 2, try to use 2 pointers. Set one pointer to the left and one to the right. Always move the pointer that points to the lower line. Always move the pointer that points to the lower line. I'm trying to understand why that works. Why you would want to do that. So we've got this here and this here. Right, okay. So if you've got this up here, and let's say this one was 8 tall, you don't want to move the side that has... So if this is right, so this is at 8, and this is at 7 here. We can see that that's at 8, that's at 7. If we wanted to keep on going, we wouldn't then go down to... We wouldn't go down to... What one would we move? Move the one that is... That's the lower line. But if you were to move it here, it would then be even lower. Yeah, it's a bit confusing. Bit confusing. Let's have a look at the next hint. How can you calculate? So I think calculating the amount of water each step's not going to be too difficult. Yeah, I'm not quite sure why you would want to. What was it saying? It's saying always move the pointer that points to the lower line. I mean, right at the beginning, yes, it makes sense to move this to the higher one because since this line is higher, it's going to be able to hold more water. Oh, right. I guess I can kind of start to see now. So let's say this is sitting at 8. This is sitting at 7, right? If we want to move one of these, then it would be beneficial to move the lower one. No, actually, it wouldn't. It would be beneficial to move this higher one here. So, yeah, be beneficial to move this one here, down to here. So I don't know why that is. Hmm. Always move the pointer that points to the lower line. I guess if you're moving the higher one, hmm, this is starting to get a bit complicated. So, if we look at this first one here and this one here, this is 1 tall, this is 7 tall. Obviously, no, we're not going to move the one that's 7 tall because when you have these two values, you have 1 and you have 7. And if you don't have any knowledge about the other points, you only know these are the 2 points. It makes more sense to move the smaller one because if you move the bigger one, let's say it's 1 and 7 here, 1 and 7. If you move the one that is 7, the bigger one, to the left, let's say this wasn't 3 here, this was a million, it doesn't matter because you're always bounded by this lower limit of 1. You're always restricted by this lower number for calculating like the max height. It's always the lower like lip of the container. So without any other knowledge, it does make more sense to move the lower vertical line. So let's go to our notes here. Try and write down some ideas. So ideas. Use 2 pointers. One pointer at the left. Just gonna call it L. And one at the right. R. Then we're going to find the volume between L and R. So the way that we're going to do that is we're going to do the lower limit, so lower value between L and R. We can probably do this up here actually. Find the lower value between L and R. We're just going to call this min. Call this min for now. So multiply min by index of R minus index of L. Then we're just going to add this to, call it a list called volume. So add to volumes list. Continue until L is equal to R. So yeah, we want to stop when the pointers like overlap almost. That's how I think we're gonna know we're done. So using this kind of idea, we'll try and put it into practice. Oh, actually, one last thing. We're gonna return the max value in volumes. Actually, we don't need to do that. We don't need to have volumes list. If the value is greater than output, replace output with this value. Cool. Cool. So let's try and write the code for this. So we're going to do L is equal to 0, R is equal to the length of height minus 1. Then we're going to do while, just going to do while true, or no, while L is not equal to R, we're going to say min is equal, or min val is equal to min height L and height R. Okay, so we've got the minimum value. We're going to multiply. Oh, that's again one thing that I missed. Move the right pointer if it is right pointer to the middle if it is lower. If it is the min, move the left pointer to the middle if it is the min. Cool. Okay, we're gonna find the volume. So volume is equal to min underscore val multiplied by R minus L. Cool. If volume is greater than output, output is then going to be equal to volume. output is going to be 0 to begin with. Then we're also going to say if L if height L is less than height R, then we're going to do, so if this is, if L is lower, we can do, well, what was the order that I did it in? Here, let me copy this back. If the move the right pointer to the middle, so just do if the right is less than the left, then we're going to do, what are we going to do? The right is left, so move the right to the middle, so R plus equals 1, else R minus equals, oh, L minus equals 1. Cool. Then we're going to return output. I'm also going to print the volume at each step. Print volume, L and R. Just to help us debug, because I don't think this is going to work straight away. Yeah. Index out of range. That's because I got these operations the wrong way around. These two cases were accepted. Let's try submitting this, see what we get. Accepted. Okay. So, thank you very much for watching that video. I hope it was useful to you. In fact, sorry, one thing before I wrap up. If we go back into here, we can now tick this off. Cool. So, thank you for watching the video. I hope it was useful to you in some way, shape or form. If it was, please leave a comment. Or if you had some other solution to this, which was maybe a bit more efficient or different, please leave a comment. Love discussing these problems and their solutions. So yeah, thank you once again for watching the video, and I hope you have a great day. Bye.